Hello, guys. Abhilash.
Yes, hi, sir.
Hi. Jay
Yeah,
Mathai ji, how are you? Great to see you. Then we have Manu, Roy Joy with a good rhythm name. Prakash ji, Jackson, Muzammil Rice is on the call. Mohammed Goda. I hope still others must be joining in a while. So, how's the learning going on, guys? Anyone would like to share their feedback? How long are you enjoying the videos, the content, the way? Abhilash, your feedback, please.
feedback. Actually, I was very busy. Anyway, I'm trying.
Okay. But is everything okay with the content? Are you able to
Yeah, yeah,
grasp the thing?
yeah.
Okay. Because see, Abhilash, the thing is, my sole intent here is to add a value addition to your life. Such that anything you see, you should be able to interpret in terms of mathematics, in terms of science, in terms of anything which helps you in your life. Simple.
Yeah, correct. Yeah, yeah,
Yeah.
that is correct. Absolutely correct.
Yeah. Last
Mhm.
last time when you would not have been part of this lecture series, you joined
Yeah, correct.
lately. Then we used to have the sessions on Chat GPT, how to use the Chat GPT, exploit the Chat GPT like anything. So we literally learned a lot hereby in this class. So
Mhm.
therefrom, the people got interested in learning few of the more things. So I kept the things hovering around the new technology. So in
Mhm.
order to learn new technology, whether call it a data science or Python or any data associated thing, because we all are into the industry where data is mandatory to be there. So I that's why I considered these numericals, or must I say these statistical understanding, because when we had nothing as a measurement device, we had the concept called statistics. So that's why in statistics we say we only estimate, we do not calculate, we estimate.
Mhm. Yeah.
That's the reason. So if we are using the correct set of vocabulary, we would be able to make the life uh, Genresa Hammer. I think, have you joined for the first time? Genresa Hammer. See, very good quality of name people are joining with. I'm literally mesmerized. Shayyad Shabir. It seems like you are watching me continuously from your photograph. Okay. So, right today, we will be taking our lecture towards understanding everything which we had covered as a measure of dispersion, or a statistical tool, or you call it, may I call mean, median, mode. Three things, that is the measure of central tendency, and two things as a standard deviation and variance as a measure of spread. This we have understood. Right today, I'll be sharing you something with my numerical abilities to let you understand that if you are given into a situation, how would you be able to apply these statistical things while calculating and drawing the inference out of it. Okay, that suppose you've been into the certain campaign, in the campaign say patient came, out of those patients, say suppose few patients do want to lose the weights and few patients do want to increase the weight. So how would you apply statistical analysis to actually consider whether whatever happened throughout the camp, is it statistically significant or no? Okay, that we are going to understand today. So do let me, I'm sharing my screen, do let me know whether it is uh, available, audible or no. Just give me a few seconds. Okay, just a second. See,
Good evening. Sorry, one more thing I just want to ask you. See, when we the practically where you apply this the statistical these calculations, or in a practical point of view.
Understood. Understood. Who is asking this question? May I know? Just 1 second.
This
Mithai ji? Okay.
yes.
So, yeah, Janji, see, have you been to the last class? Yes or no?
Yes.
Okay. If you were been into the last class, the last, may I say 15 minutes, we only discussed the application of statistical analysis. If you had paid attention to, then we understood that this.
Remember the best terminology, isn't it?
Yes, the terminologies we understood about whether are you going to estimate the variance in a stock market, are you going to look for education, say sometimes, I'm being into a teaching profession, okay? So being a teacher, thereby it is expected out of us that we do a good rating to the people or to the student. So that good rating is being actually calculated using the population size. Say suppose in my class, if I have a population of say 25 people in class, suppose 25 students are there in a class, and I have to provide the statistical understanding to the result obtained in an examination. So if there are 25 minded Genji, I am not able to apply normal distribution curve. Hope you remember normal distribution curve as a bell curve. The bell curve, that bell curve we cannot apply less than 30 people, 30 sample size. Only if you are having a 30 candidates or a 30 entities or 30 object, only then you would be able to apply those normal distribution and then standard deviation and likewise thing. So we also follow certain set of assumptions. Say if you cross 30, then such kind of statistical analysis are under consideration and they can be taken well at hand. Else you are simply faking out the things. First thing. Then if you go about in the analysis of finance, say if you are going for a fraud detection, say some fraud used to happen in your credit card, that fraud detection is whether a legitimate or illegitimate is also being understood with the help of standard deviation. Say if a standard deviation, say you used to go for spending suppose 50,000 rupees per month, okay, and all of a sudden if the expenditure raises to 5 lakh rupees, one extra zero, then isn't it a probability of a fraud to your card, Genji? Yes, no? Yes. So
Yes.
that is being only understood by the machine sitting somewhere else by these mathematical instances, which we call variance and standard deviation. Because you usually spend 50K, 60K, 45K, 35K, 62K per month, and all of a sudden, if it goes 50 lakhs, the person will call you, sir, we found one transaction on your credit card, it is 50 lakh. Is it you who is doing it? A person will call you if it is a good company. So, but a person is not tracking Mr. Jan Mathai. Person is only watching his screen, and that screen is showing that some big amount is raised on Jan Mathai's account. So then a Jan Mathai shall be called upon by the customer care that so and so company is calling for, and you will say, no, it's not me. Please block the payment. That is the one aspect of this. So everywhere, say if you are working in a company where data matters a lot, and say, okay, give me an instance, which company do you work? Means what type of product your company builds? Unmute yourself and answer me.
I work in facility management. So here we have especially energy management. So we have to calculate the energy consumption of the different equipments, and we need to compare with the previous year. So then if it is going high, so then we need to analyze. Sometimes the meters will malfunction, so the reading will be high. So we have so many meters, around more than 1,000 meters. So we don't know from which meter this wrong data came. So we have to find out then and correct that meter, or then all these values we need to every month we need to record, and we need to analyze that one. So if any equipment is going faulty, then that would also take more current.
Understood, Jayanti. Understood. See, as you have indicated very best to your abilities about the company and the product. So suppose if you got the correct instrument from which you were measuring the energy and it went a very high. So first thing, if it went very high, it means there is certain variation which was not allowed and which is detected by the controller or a sensor. First thing. Second thing, this analysis which we are doing can be used in order to calibrate your instrument. Calibration. Say suppose if you are going for a if I give a name around energy meter, consider energy meter, and energy meter, three-phase energy meter, which used to go for maximum voltage of line to line voltage 440 volts, suppose. So 440 volt is there. So that 440 volt, suppose if it goes 512, 570, isn't it a very high deviation? Yes, it is a very high deviation in case of electrical engineering and energy engineer. So that calibration of instrument, being an energy meter or being any meter, is done with the help of Muhammad Goda. Please mute yourself. Muhammad Goda, please mute yourself. Okay, so you are supposed to calibrate your instrument using those statistical measures, Genji. So hope I would have made an answer to your question. So I can understand, because you every day work a lot, comes to the in the evening you have a class, and all of a sudden this guy is making a lot of things about theoretical aspects of life.
Actually, I was night shift yesterday, and I came 12 o'clock, so I didn't sleep, because if I sleep, I will miss your class. That's it.
So my goodness. You can also see the recordings. I think management used to share it. So, but no worries. There is a good thing about it. So, right today, I'll be taking your question and giving you certain handouts of numerical practice. Okay. So, do listen to it very carefully. So now I'll be sharing my screen. Do let me know whether the sound is listened to you or no. Am I audible here?
Yes.
Okay, please carry on.
No, the audio is playing. We can't hear.
Audio is not audible.
Is my audio not audible?
Not audible,
not
sir,
audible.
in video.
You're not audible?
Yes, sir.
Okay, 1 second. Thank you for this. That's why I asked you. And you said yes, audible. Second. Just making this for share annotation side control. Hope this should be audible. Let me stop share and reshare it. Because if I share it, I'll be sharing the sound. Optimize for this clip. Now it should be audible. Do let me know.
Bottles. So create any company is there.
Is it audible now?
Yes, sir.
Yeah, the starting it was coming, but after that, no.
Okay, wait for 1 minute. I'm just playing it. Please do let me know.
quite new in the market. Hence, we call it a startup because the scale is also low. Over the past 6 months, so we having again, can you see? We have written past 6 months. So sooner
Is it audible, man?
Yeah, audible.
Yeah,
Okay.
now audible.
Thank you.
you identified the term past 6 months, you should always make a note in your mind that it is a descriptive or descriptive come historical data is going to be presented. Are you able to correlate what I'm saying? We had done it rigorously in our learning of descriptive statistics. So you have collected data on the monthly sales, say any product, and that product is eco-friendly bottles. So sales figure, consider the sales figure in thousands of the units. So if these are the sales figures here, sales figure here. So it says 15 means 15 thousands. So every sales figure considered to be K, K, 15,000, 20,000, 22,000, 19,000. K reflects thousand in mathematics. Like you go to a vegetable shop and ask, please give me 2 kgs of potato. So you are asking 2000 grams of potato. So try to think in that fashion. Moving ahead and solving our question and learning the concepts. Customer satisfaction ratings are given. That's definitely in out of 10. So it is a kind of ordinal data where certain they are arranged in an order. Something is comparable with respect to each other. So such a kind of uh, feedback or a kind of rating is usually called as ordinal data. Ordinal data, which this we shall also cover while learning the concepts of data analytics with respect to mathematical statistical mathematics. So moving ahead, so this is the data set we have. Now the task at hand is calculate the mean, median, and mode of the sales figure. I hope this seems quite easier to find because we have learned it from our latest understanding of measure of central tendency. So may I say, if I'm going to answer the first section of the question number 1, or say I write, okay, let it be. So answer 1, first section. So it is actually asking me the measure of central tendencies, yes or no. Revise your notes and give me a positive answer. To measure of central tendencies. So they are again mean, your median, the middleman, the middle guy, and the mode, the most popular guy, that is the mode. And mean is the bullseye. Remember from our last module and the story. So mean, median, mode of a sales figure to be calculated. So let's start. So you remember that mean is actually given by the addition of all the values divided over the number of values. So what we are going to actually calculate sales figure. So sales figure are given as 15,000 to 22,000. So you may write it as, say, if I move it up. So we may write it like 15K plus. Okay, you may add them in any fashion. It's not necessarily that you add them in an ordered fashion. So as they are written 20K plus 22K plus 19K over how many values? 1, 2, 3, 4, 5, 6. Very good. 6 divided over 6. So when you add them, I think it should come out to be when you add 15 plus 18, then 12, then 20. You may use the calculator because you are now at such a level of academics and business, that you should use the calculator such that you need the final output as the correct one. So it comes out to be 106K divided by 6 and almost equals to, if a calculator gives me an answer, 17.67K. So got it? So our mean, the bullseye is 17.67 thousand. So this is the mean value of the sales figure. So out of all the 15,000 till 22,000, 12,000 to 22,000, it says only when you come to 17,000, that would be considered as mean, and it will only be taken for all the future references and calculation of either variance or a mode, sorry, either a variance or a standard deviation or a skewness, whatsoever is asked. Please go for a median. What does the median say? Median. So do you remember, to calculate a median, what is required? I hope you remember. We require an ordered fashion, ordered nature of number of, must I say, ordered nature of data. So we have a data of sales figure. Consider them arranging in an order. That's it. So if we arrange them in an order, it comes out to be 12K, then 15K, then 18K, 19K, 20K, finally 22K. You need not to necessarily arrange it in an ascending order. You may go for in a descending order as well. So you may write it as 22K, 20K, 19K, 18K, 15K, and finally 12K. Any order is preferable. Why? Because when you move from left to right or right to left, the middle value is to be taken. But here, what is the middle value? If you move 2 points in the left and 2 points in the right, these two are coming as a middle value. Because if you move 1 point again and a 1 point in the right, there is nothing between them, because they are even number of data, sales figure, even number of sales figure. So whenever the even number of sales figure comes into picture, you are required to take the mean of them. Again, an arithmetic mean of them. So here in this case, the median shall be calculated by 18K plus 19K over 2. And it will definitely 18.5K. 18.5K is the median, middle guy. Okay, would anybody focus for mode? Just have a look to the data. Have a look to the data. Where is the data? 1 second. Here it is. Check the mode. Is there any number, mind it, is there any number here which is getting repeated even by one time? So 15 unique, 18, 12, 20, 20, 20. No uniqueness. Sorry, only unique data is placed. So you can write here, you can consider it as a unique data. It is a unique data. So you may also consider it like no repetition is observed. No repetition is observed in the data. Hence, if there is no repetition, my dear, then consider mode to be absent. So there is no mode in this. You write an answer as no mode available in the data set, or you can interpret like that there is no popular number. No, there is no popular sales figure for a given data. Every sales figure being a unique, hence for every sales figure we have a different mapping to customer satisfaction. So there is nothing no popularity is associated with the sales figure here. So are you now able to correlate the figures, the digits, the data to the real world understanding, like how I and you are talking right now, how I am speaking something. I'm not speaking numbers, I'm speaking literal words which make sense in a real world. Hence, always try to associate your numbers to the physical significance of them. Then the second question, or the second, not the second question, second part of the question is, you are required to find the variance and standard deviation. I write it in short, standard deviation of customer satisfaction, customer satisfaction ratings. You may also find the variance of the sales figure and the standard deviation, but here we are being asked what would be the variance and standard deviation of customer satisfaction rating. You remember the formula for a variance again? Variance is, if I write a variance as sigma square, if you remember, sigma square says that you need to take a number, whatever the value in a given data set. So X minus the mean you have calculated and take the difference. Sooner you taken the difference, square it up and then average it. So sooner you average it, you have to divide it by number of data points as well. Number of data points as well. So this is the main thing. But do we know the mean now? We have the data set xi. Remember, we have a data set and this is the data set. Customer satisfaction out of 10. This is the data set for the second question. Second, this part of the question. So xi is available. So consider this as an xi for this second portion. So what would be the mean? You need to calculate the mean.
Sorry, the text is not very
So
clear.
because whatever mean you calculated in the above.
Yeah. What is not clear?
The text, no. Yeah, now it is. Yeah, now it's clear. Yes.
Okay. Yeah. The text was not clear, or the voice was not clear.
Letter means
The text was not clear
text
to either.
was not clear before.
Oh, okay. Actually, it might happen due to internet connectivity, but rest everything is things are done in HD. Okay, I'm running it.
Okay. Okay. Thank you.
Question, above section, this belongs to the first portion of the table. You have not been asked the variance of the sales. Mind it, sooner you have been asked the variance of the sale, the effort becomes easier. You have already calculated the mean. Congratulations. But mind it, you have to calculate the mean of these number again, such that their variance and standard deviation could be calculated. Very good. So moving ahead for mean. So mean could be calculated by, if we have a number, I have written a number separately for my reference. So may I add them, like satisfaction survey won't go greater than 10. So 8.5 plus 9 plus 7.5 plus 8 plus 9.5 plus 9. How many are they? 1, 2, 3, 4, 5, 6 divided over 6. Very good. So you got the answer of 51.5 over 6, almost equals to, say, 8.58. So the mean is achieved. Congrats. We have found the correct mean. We have found the correct mean. So write it as a mean of C, write mu C. Why? Customer satisfaction. Mu CS, customer satisfaction. Else it should not create a ambiguity to which mean should I use? So again, use the value of a variance. So variance can be calculated as, again, now it will go line by line. One is the value. What shall we do? We will take the values like these values. First, we'll take 8.5. We take a difference from the mean of 8.5 and then square it, like 8.5 minus what is the mean? I think 8.58. Yes, 8.58. Calculating them and putting a square to it. And we shall do it for every other number. Every other number. So we can write it as 8.5 minus 8.58. Now you must be able to understand why we had done the square, because sooner this term is greater than the previous term, this becomes minus, and to avoid the negative values, because it's a square quantity, to avoid the negative value, we could have used the modulus also, but modulus was not able to cover the exact spread or the expect dispersion. It was giving the same variance for a more dispersed value as well. Hence, we opted the square. So add them. The next value becomes, I think, 9.0 minus 8.58 whole square, plus it becomes 7.5 minus 8.58. I hope you must be able to get it through. You only require to write 3 more values, my dear. If you have a choice, you can do it along with me, such that your confidence should be boosted by either means. So we had covered 5 values. The sixth one is 9. Whole square. How many? 1, 2, 3, 4, 5, 6. Divided over 6. Divided over 6. So if you try to calculate it, so I believe it should come around this. 1 second. Let me try to calculate it for you. So it comes out to be, say, minus 8.58 minus 0.8, 0.08, 0.08 whole square, plus 0.42 whole square, plus minus 1.08 whole square, plus, correct. So it is 0.92 whole square plus 0.42 whole square. And you divide it by, again, 6. So if you go and calculate it via calculator, you will find your answer to be around, I must say, 2.7084 divided over 6 comes out to be almost equals to 0.45. See, the value of the variance is coming as 0.45. And sooner you found your variance, the standard deviation can be simply found by square rooting the variance. Or so it comes out to be under square of 0.45 almost equals to 0.67. Okay. 0.67. 0.67 is the value by which the data set is getting deviated from, again, the bullseye. Who is the bullseye? Mean is the bullseye. So how to interpret this data? That the other say data entry or the data points, or must I say here the data points are customer satisfaction factor So these data points of customer satisfaction factor is deviating by 0.67 from mean of CS, which is equals to how much we found it? 8.58. Are you able to connect the findings? Say you had a mean of line 8.58. This is a mean line, which is equals to 8.58. So now the rest of your data is only 0.67%. 0.67. The standard deviation is 0.67. Although we do not have any negative value here. So this is how to calculate from the mean. Then let's see what had been asked next. So the value of variance is found to be, say, point, how much it was? I believe 0.45. Yes, 0.45. And the standard deviation is 0.67 of the customer satisfaction rating. Now you are required to determine the skewness and kurtosis of the sales figure. Let me write it and discuss. Third point, or the third question of the main question is, the third section is, find the skewness. What does the skewness represents? If anybody remembers, asymmetry. Asymmetry. If the skewness comes positive, we say the asymmetry is say positively skewed. We will say, like, say your data set is like this. If it skewness comes out to be a negative value, see, mind it, I'm talking about a scalar value, real value, magnitude. So then for a negative value, we'll say that your data set is negatively skewed. So let's find what could be the skewness for our problem at hand. Let's solve. So if you remember from our last class or the last module, the skewness is actually a coefficient. We find the coefficient of skewness. Coefficient. So few coefficients is given by scientist called Pearson. Few coefficient is given by certain scientist starting with the name B. Okay, so we have to find SK or okay, simply go for skewness. Skewness. Now I'll neither write P nor I'll write SB. Why? Because they both are being applicable on a different note. For Pearson, you need to have either a mean and mode or mean okay. So for that value of the data, we find for Pearson, and for when we go for P coefficient of skewness, then usually we go for quartile. Quartile. Here we'll learn a newer thing. So I'll simply write skewness only. The newer thing says when you are having number of data point, mind it, number of data points. So the number of data points is being usually reflected like, say, if I go for a formula, so it says n over n minus 1 into n minus 2 summation xi. Xi means all the data points minus what is mu? The mean over standard deviation, I'm writing sigma, not sigma square, over the standard deviation, whole cube. For the time being, please, I'm just removing this quartile. Consider this whole cube. So what's the value of n here? Number of data points. You remember we have 6 data points because we divided by 6 while calculating the mean. So n is equal to 6. Sooner you know the 6, and now you also know the mu. Because just have a look to the question. It is being asking the skewness of sales figure, not the customer satisfaction. So the skewness of sales figure is calculated as 17.67. Can you see here? This is for mu of sales figure, mu s or SF, sales figure. So always be cautious which mu you are using. So mu SF. So this mu is mu SF. So 6 over, sorry, I'll again write it. I have made it n equal to 6. So now skewness will be calculated as 6 over 6 minus 1, 5, 6 minus 2, 4. 5 into 4 summation. Say now you have to make xi minus what is mu SF 17.67 if I remember correct, whole cube, no, divided by standard deviation. What is the standard deviation here? The standard deviation you are required to calculate for it. You are required to calculate the standard deviation for it. Okay. So again, standard deviation calculation is as similar as this. You have to go for a variance, standard deviation, and under root of the variance, and you shall be done with. So standard deviation, please calculate for it. So make it a cube of it. So when you put a value here, say you put one value called sales figure, the sales figure say 15K. So 15K minus 17.67K, say standard deviation comes out to be 0.8K suppose. So 0.8 divided by, then you make a whole cube. Whatever answer would come, then add it n number of times. So I have an answer to it. Please match after you are done. So skewness comes out to be approximately minus 0.45. Minus 0.45. So it is called a negatively skewed. Negatively skewed. What does it mean? That your data set, without even drawing it, your data set is like this. Yes or no? Yes. Your data set is distributed like this. Or this might be a situation that the data set goes like this also. Either way is possible. I'm only giving you the visual impact that from the skewness, what have you created a picture in the mind? It is not like solving a maths and getting an answer or getting the marks out of the answer. It is like what have you interpreted out of that particular value? Okay. Okay, fine. 1 second. Let me make the things. Use the marker, your own marker with pen tab, and you can increase the number of pages as per your suitability. So if you go for finding the kurtosis, we haven't find the kurtosis. Had we? No. So if you go for finding the kurtosis is calculated as n into n plus 1. It's again a big formula. n minus 1 into n minus 2 into n minus 3 summation of xi minus mu over sigma, almost similar with kurtosis, but raised to the power 4, minus of 3 times n minus 1 whole square over n minus 2 into n minus 3. That's the reason, my dear, the machines used to calculate the kurtosis and skewness for most of the time. Then only the skewedness comes into picture and the data distribution is justified. So here the kurtosis would come out to be, say, number of data point are 6. So 6 into 7 divided over 5 into 4 into 3 summation of, I'll write xi minus the mu, that is 17.67 divided by standard deviation, say 0.8 whole raised to the power 4, minus of 3 into 5 whole square divided over 4 into 3. So when you solve it, the answer will come out approximately to be say 1.12 minus of 1.12. So what do we understand from a kurtosis to be negative? Kurtosis to be negative. Do you remember how many type of kurtosis things we had? Like, yes or no? We had multiple kurtosis values. Yes. So if you go for, say, the last one, so it is out to be platykurtic, like a plateau, negative value. Platykurtic. Platykurtic. So from it, we can say that the distribution is, although towards it's a negatively skewed, but there is no peak. It's not leptokurtic. It's a platykurtic. So there is flatness in the peak. So the data set could be given like this and this. Okay. So this is called platykurtic. And you remember, whenever we have a platykurtic of data, we have higher standard deviation rather than when we have a leptokurtic of the data. Because any leptokurtic of the data will have this pointed peak, and see the standard deviation is very less, very less. It's deviating almost negligibly with respect to the mean. So here SD would be higher than that of SD of leptokurtic. So these are the things you should keep in mind, that yeah, what is the meaning of negative kurtosis, what is the meaning of negative skewedness, and please apply to your level of physical interpretation or normally the interpretation. Okay, fine. So if I go for the next question. So here we usually say that sales and customer satisfaction have a literally it tends to have a good customer satisfaction, and it tends to be associated with higher sale. Can you see? 15K sales 8.5. There is no customer satisfaction feedback or a review below 8.8, below 8. So when sales are in 20,000, there it is low. When the sales are in 22,000, again it goes 9.5. And when the sale is having very less, 12,000, it's going 7.5. Yes, there is 7.5 as the lowest one, not 8. So 75 out of 100 is a good approximation, or must I say is a good review. 7.5. Like you go for a review of a mobile phone before purchasing it in a Play Store if you are in India. So similarly, you should also check the customer satisfaction rate or customer satisfaction figure. So moving ahead, I have taken although so much of pages. Okay, if I remove it back. It's fine that if I take them back. Okay. Okay, so I have brought my second question over the second page. No worries. Okay, 1 second. Okay. So this is our question number 2. Question number 2 says that say you are working as a data scientist somewhere in a good reputed company. Now here they say as a data scientist at a healthcare clinic. So always remember in your mind, healthcare is usually a sensitive platform where a sensitive data comes in. So being a data scientist working at healthcare clinic, you are tasked with analyzing the weight loss, mind it, you are analyzing the weight loss progress of patient over 12 weeks program. So if it is a 12-week program, how many months? 4, 3 are 12, 3 months program, 3 months or 12 weeks program. Every month has 4 weeks. The weight in kgs of 5 patients at the start and end of the program are as follows. So they have taken start weight, means when the program started, they took the 5 patients. When the program end, the same 5 patients are being taken because they are analyzing weight loss progress. So they have to analyze the weight loss for the same patients. It is not like they have taken a patient A in the starting and now they are writing for the patient C in the end. It is not so. So we can analyze also that the weight of the patient A is being decreased by 5 plus 2 by 8 kg. Yes, by 8 kg. No, 7 kg, not 8. 5 plus 2, 7. By 7 kg. 78 plus 2, 8. 80 plus 5, 85. Then again, here it says it is decreased by again 7 kg. 3 and 88, how many? How much? 6 kg. Then 76, 72, 4 kg. 90, 95, 5 kg. So see the difference we have written along with the end weight. So we might create one more column observed. So again, now it becomes easier. So you please calculate the mean. So
Yes. So what did you learn? Abhilash ji, Jain Mathai ji. Anyone else? Sayyid, Sabir, Manu, Shravan, Muzammil, Ranjit. Ranjit, show your face. Prakash ji, Prasad. So what did you learn from it? We calculated the things. You may unmute yourself. We calculated the things like mean, median, mode, then standard deviation, variance. We had the data and multiple things we had seen. Newer things. Can you identify me 2 new things you learned today, which were not discussed before? Any idea?
Yeah. Skewness and kurtosis.
Oh, great. You are following the notes. Abdauji, any idea? Have you ever learned skewness and kurtosis before? Prakashji, what do you say? You guys are mute. You guys are mute. Unmute yourself.
Sir, no, noted, sir.
So this was the motive behind this numerical practice, that I should give you one extra thing, that is I have shown you as a skewness and kurtosis. And okay, would you like to give me a summary that what did you learn from skewness and kurtosis? Because everything else we had learned. So what did you learn from skewness and kurtosis? Try to remind to your brain.
Negative value, sir.
Yeah, negative value, but yes. So Ranjit ji has remembered that we got negative value. But what does that negative value represent, Ranjit ji? If something was negative, say suppose if your skewness is negative, if a skewness is positive, if a kurtosis is negative or positive, it must represent some physical significance. Yeah, yes, those physical significance says that, say suppose we all are born as a human, but few are fatty, few are thinny, few are healthy, few are athletics, few are spongy, or anything, call it anything. So we all have some measurement in order to define this particular type of identity. Similarly, when our data set is concerned, if a data set measurement, or must I say the data set estimation via kurtosis comes to be negative, we call that this is almost standard deviation is very large. We have not drawn our data, but only calculated the kurtosis. If it comes out to be negative, we will say standard deviation is very big. At the same time, if you go for skewness, if skewness becomes negative, we say the whole data, the whole set of data is towards the left, Similarly, when the skewness becomes positive, we say the whole set of data is concentrated towards the right. Means the data is not normally distributed. Hope you remember normal distribution, the bell curve. That bell curve says the data is normally distributed. It is neither more towards left nor more towards right. Whereby whenever these quantities like skewness, actually skewness is showing you the symmetry. If a skewness goes 0, it is symmetrical data, like a parabola, inverted parabola. Similarly, if a skewness is negative, the parabola is given a jerk towards left and the parabola shifted mostly towards left. If a skewness goes positive, we say parabola is shifted towards right and it shows likewise. It is similar like you have a what is called a piece of thing and you have filled a sand in it, and if you are pushing the sand towards right, it is showing the positive skewness. If you are pushing the sand towards left, it is showing the negative skewness. So these are the things we should take care about. Isaiah, please mute yourself if you are not talking to me. Isaiah, mute yourself. People forget after they open their
They are
mic.
in class. They forget they are in class, sir. My friend, please mute yourself.
Actually, I don't have authority to mute this guy. Well, else I would have done that. My God. Okay, so I have shown you the second question, that is towards the weight loss program, that health clinic weight loss program. Please take the screenshot of that and calculate everything. Shall it suffice?
Yes, sir.
Yeah, please take the screenshot. I'm sharing the screen again. Take the screenshot. Please take the screenshot of this. Let me make it back. Yeah. Do let me know sooner you've taken the screenshot. Done?
Yeah, done.
Sir.
Okay, thank you.
Yeah, done.
So, sir,
So-
can we say the sequence means lower to high in simple way?
Which sequence, Rajitji? Which sequence?
No,
Acha,
sequence no.
skewness.
Yes.
Yes. See, mind it. Consider that you have a full sandbag, and that sandbag, once if somebody is pulling it out towards itself, and that person is towards your left, so all the sand will shift towards left.
Yes.
And if you are pushing it towards the right, first it comes to middle, and then it goes to right.
Right. Yes.
So in that fashion, if the whole sandbag is on left, we call, from the mathematical term, we will call negative skewness. So whenever you find the skewness via your machine or a calculator, if it comes negative, write the answer, it's negatively skewed. Data is negatively skewed. But if it comes zero, you will say data is properly balanced. It is normally distributed. But sooner if the skewness comes positive, you will say my data is positively skewed. It is more shifted right from the origin. Or will I say not right from the origin? I will say right from the mean, because normal distribution curve is about mean. Whenever you calculated the standard deviation, it was from the mean. Say if you consider that, say suppose this portion of your face is swallowed. If this got swallowed, you will say that your face is rightly skewed because this is swallowed right from your center of the face. So you will be rightly skewed in that. So learn the things in a humorous way, then only you will remember it. So if you have taken the screenshot, please maintain that next time we join, you should have done that question. And we will be discussing that question again along with other questions of a good quality. And after that, we will be starting a new topic.
Actually, sir, we need all classes video recording, but not sending by the. You don't think, sir, we need all classes video recording?
I think so. You think so. Even management thinks same.
But management is not sending, sir. This is the problem.
But you should request them. Please request them. They will definitely send you. Have you requested them?
Yeah,
I didn't request, but
because we are asking that they are forwarding.
Okay.
You are
so have you found it?
No, sir. I never found until now any classes recording, sir.
Okay.
So through WhatsApp you can ask.
Okay.
Okay,
May I ask?
now.
Yeah. Athiraji, if you are here, could you please answer Ranjit and other participants? Athiraji, if you are here, Eduwing Education, Athiraji. See, she might not be here, might not be responding. But again, I will be raising this question from your behalf. Please send the mail and then allocate the classes.
Yes, sir. So, sir, at the class time, we cannot keep all things in our mind. When you can understand, sir.
Yeah, I understand. Even I have to prepare notes, man. I am not everything. Okay. No worries. Chalo, for the time being, gives your thumbs up if you loved this class today.
Thank you, sir.
Thank you so much. Thank you, Janji. Thank you, Abdauji, Abhilash. Jahir Ahmed, he is still driving. Enjoy, man. Drive safe. Roy Joy, please come. Great. I'm taking a screenshot. Okay. Thank you, guys. Take care.
Sir.
Enjoy the night. Drive well. Have a good food. Bye-bye.
Bye-bye, sir.